power of high-speed internet is in the palm of your hand. That's quickly becoming a reality for anyone with a 5G-enabled device, thanks to the continued rollout of 5G networks. But we've barely scratched the surface of this technology. There's still a long way to go in terms of infrastructural development before we can truly reap its benefits. While efforts have been underway in the U.S. to make the next generation of wireless networking accessible to more people, the Federal Aviation Administration wants this tech far away from airports. According to the FAA, 5G infrastructure may interfere with the safety of the aviation industry. But is there any validity to their concerns? Is 5G dangerous for planes? Most of the FAA's concerns emerged when U.S. telecom companies announced they were opening a channel for 5G networks to operate on, so its true potential could be unlocked. The C-band. While 5G networks have been available for public use since 2019, most of these operate on millimeter-wave high-frequency bands, which have a limited range, or lower-frequency bands, which gave users a negligible improvement over their 4G speeds. Just like with other forms of wireless networking technology, data is transmitted over a 5G network via radio waves, an electromagnetic signal that's able to carry information through the air across large distances. The speed at which data can be transferred over a network is determined by its frequency, or how fast the waves cycle per second. These cycles are measured in hertz, and modern networks transmit data over waves cycling billions of times a second. For context, most home Wi-Fi routers transmit and receive data at 2.4 GHz. On the other hand, the new cell towers built to transmit data over the C-band operate within the range of 3.7 to 3.98 GHz. But herein lies the problem. The C-band is dangerously close to the band in which an airplane's radio altimeters operate, generally between 4.2 to 4.5 GHz. This is especially problematic as the C-band has been touted as the Goldilocks frequency due to the frequency range's ability to deliver both fast speeds and wide coverage. Some planes also use older radio altimeters that don't filter out other frequencies altogether. This same vulnerability is why airlines require you to turn all your electronic devices off during landing and takeoff. Radio altimeters give pilots a very important piece of data, the plane's distance to the ground. They measure how far a plane is from the ground by bouncing a radio wave from the aircraft to the surface below and recording the amount of time it takes for the wave to return to the aircraft. In low visibility weather conditions such as heavy fog, snow, and rain, these tools are crucial in helping pilots safely land planes. Meaning in a worst-case scenario, an incorrect reading can spell the difference between a safe landing and tragedy. So does this mean the aviation industry and 5G can't safely coexist? Thankfully, no. The first safety measure the two parties agreed upon was to create 2-mile exclusion zones around airports in the country. Major U.S. networks such as Verizon have complied, keeping any 5G cell towers within these exclusion zones off in the meantime. Eventually, subscribers living within these exclusion zones should have access to 5G as well. Although the FAA's due diligence on this matter is good from a safety standpoint, you have to wonder why they waited right before C-band's U.S. rollout to cause a stir. In other parts of the world, the aviation and telecom industries work together to roll out 5G as safely as possible. Countries like France and Canada feature buffer zones around airports, where 5G signals are restricted and cell tower antennas must be tilted downwards to prevent potential interference. Some countries in the EU even have 5G networks operating at lower frequencies than what is planned in the US. This grants an even greater allowance between them and the frequencies radio altimeters operate on. Just a little foresight on the US's part could have saved a lot of time for a lot of people.